We're here at BCMC 2025, just an exciting show. Excited to sit down and talk with Barrett Ames. What's your official title, Barrett?
Yeah, I'm CEO of BotBuilt.
We had a long conversation last night. You've got some exciting things that you're working on, and
Yeah, definitely.
it's just neat to see the innovation happening in this space. How's the show going so far?
Show's going great. We've had a ton of interest. It's actually my first show.
Yeah.
So also just great to see everything that's out here. I think coming and seeing you guys, finding out what Paragon's building, very, very cool.
There's a lot of talk about innovation and AI and all the different things that are happening in this space, but what are some of the conversations that you're having with people?
Yeah, I think, the labor shortages, the skill shortages are driving a new level of adoption, paired with just a lot more practical approaches to innovation, right? Like automation's got to work with the labor force that is here. And so just being able to provide things that are more akin to power tools, right? Like we want to take somebody and make them a 10x of whatever they are, right? And so for us, that really means taking carpenters, taking framers, and making them 10x faster. But getting the robots to do the drudgery and let them be the artist, right? Let them be the craftsman.
I love that. That's a great way of thinking about it. You've got so much that can be done in the design phase.
Right.
And we're used to seeing machines like the roller presses. And sometimes once you get a motor in something and it gets a little bit more autonomous, it feels scary, but at the end of the day, it's a tool to be used by people doing creative work.
I very much feel like robots are taking that job that is so repetitive and just real drudgery and letting people be so much more creative, right? And like, not only does that make it better for labor, it also makes it better because the homes get better. They're more they're closer to what people actually want to live in. They become inspired by the house that they live in as opposed to just another box.
Yeah, absolutely. That's interesting from our perspective because we're on the design side,
right?
And we're trying to get people to think about the possibilities of designing and manufacturing things, but also what are the possibilities for integrations.
Yeah.
And so that's something that we've been focused on this year. And talking to you last night, it's exciting to see somebody else that loves the idea of finding ways to more easily integrate and do what you do best, and then get it over to you guys and do what you do best.
Right. Yeah, because I mean, it's a massive market. There's problems everywhere that we turn, and like, I'm not going to solve them all by myself. So it's great. Like I think probably one of the highlights for me this year is finding you guys and what you do, and just like we do automated wall panel design. We can do takeoffs for walls, and we've got like the shell for roofs. But we don't do truss design. Yeah. And I knew in my heart that someone had to have done that already.
Yeah.
And so it immensely validating for me to like get here and find you guys doing an awesome job at it. I was so excited when I found out about it last night that I went home and started working on the integration immediately.
Yeah,
so
I love it.
I think you guys are building something really cool.
That's great. That's great to hear. From the estimations piece, we talked about this a little bit too, and I was interested to know and just pick your brain a little bit on how hard was it to find a way to get things from a PDF down to that list of the takeoff.
Right. Yeah. No. It's a very difficult problem, right? And it was actually one of those problems where I thought, certainly somebody has already figured this out, right? And when we started out, I went to a bunch of structural engineers and was just like, hey, you guys got to have a tool for this, right? And they were like, no, we don't. And it'll be 20 grand if we do it. Yeah. And I was like, oh, that doesn't work. Yeah. And so we spent the first 18 months just figuring out all of the details, all the stakeholders that go into that design, and building a data set that's big enough, right? Because AI is driven by data.
Yeah. And so, without revealing the secret sauce, you guys are essentially taking that PDF in either image form or straight PDF form, and then able to, give you an entire list. Are you able to do the model, generate a model as well?
Yeah, so we go all the way to building a CAD model, modeling nails, spacing on nails, type of nail, right? So if we've got pressure treated bottom plates, it's galvanized nails going into it, right? So and we have to do all of that modeling because that's what the robots use, right? Like that's the recipe from which the robots are cooking.
Yeah.
So yeah, no, it's a very important step for us.
And you kind of see people get interested in that first, obviously,
Right,
and the
right.
possibilities there.
Right.
And then they make the jump to seeing, okay, now I see how much it would take for a robot to do this, or
Right.
for it to be included in this package.
Right. They're very reinforcing, right? Because the takeoffs, like the best estimators are framers, right? And so we get to validate our estimates by saying, hey, we built this house, right? Like here's all the lumber and all the nails that we used, right? And so we get this feedback cycle that a lot of other estimators just don't have.
Yeah. It's interesting to think about the possibilities of errors being caught at that stage too.
Right.
Have you found it being able to flag errors or do something where it finds some of those missing gaps?
Yeah, definitely. Like a floor plan simultaneously has too much information and not enough, right? So in some places, it's very easy for us to say, hey, these two dimensions don't line up. I think probably the best example is we got a floor plan, we built the model for it, and none of the walls touched each other. And so it flagged it, and we called up the architect and we said, hey, none of these walls actually connect. And what it ended up being was the architect didn't like fractions and just got rid of all of them.
Okay.
And so like relatively easy fix, and that's actually now just encoded in the system, right? Okay. So there are like a bunch of these common sense checks that framers are doing, right? And we're able to put those into the system, and it just automatically fixes them now.
Yeah, that's really neat. Yeah, because a lot of people think about it like, oh, it's 20 feet there, 10 feet here, 20 feet there, and it's kind of easy to say, but then you start lining up the walls, and it's like, well, for this to be 20 feet inside or outside, you've got to have some fractions inside.
Right. It also opens up a really interesting feedback loop to the architect, because many times the floor plan will get to the framer, and they'll just fix it, and they don't say anything.
Yeah.
Right?
Yeah.
And it's not that the architect wants to have a bad floor plan. They're just not getting that feedback.
Yeah.
And so we can help them get that feedback.
Absolutely. And I've heard component manufacturers talk about part of their value add is kind of validating some of those plans and making sure that this does work.
Right.
And I think in a perfect world, you'd have the ability to find out some of that feasibility beforehand, before getting to that stage, either on the cost front or the, even the physics front. Like, is this going to work?
Right. Yeah. No, I completely agree. Right. Like I think great art comes from good constraints.
Yeah.
And so anything we can do earlier in the process is going to make a better home.
Cool. Well, it's so good to talk to you. Thank you so much for stopping by and recording a little video.
Thanks for having me.